All right, we will start identifying binomial factors. We actually want to try and identify the easiest ones. So we're going to go back to multiplying some of the nicest expressions to multiply. So if you remember, when we were multiplying conjugates, this was actually a really nice multiplication. And conjugate factors, these are binomials where one is plus and the other is minus. We have the terms 1 plus 1 minus. And what was nice when we did this is that the first term, when we multiply the first term, we get just that term squared, 2x times 2x, which is 4x squared. The last terms is the second thing. 3 times negative 3, we're going to get negative 9. Now, the middle terms come from the smile. That would be a positive 6x and a negative 6x. And so there's no middle term. So anytime we multiply conjugates, we're just getting the first term, which is going to be a perfect square, and the last term, which is going to be minus, because I'm multiplying positive and negative, a perfect square again. So what we want to do is look at this expanded expression. How are we going to be able to recognize that the factors of an expression like this are actually conjugate binomial factors? So we want to be able to recognize expressions that come from multiplying conjugate factors. So down here, I'm basically generalizing this expression. So you notice it has two terms. The first term is something squared, and then I have minus something squared. So if I have this type of expression, then it will come from multiplying conjugate factors. And the factors are going to be a plus b and a minus b. These are the conjugate factors. So we want a way to kind of help us recognize this type of expression. And so we explain it as the difference. So it is a subtraction. It's the difference of squares. Basically, I'm subtracting two terms that are exact perfect squares. And if I have that, then I know it'll factor to conjugate, factors. So let's try these examples. And again, what I need to do is recognize the expression. So if I wanted to factor x squared minus 4, there's no common factor, but I notice it's two terms. It's a subtraction between two terms. The first term is a perfect square, and the last term is a perfect square. So this is a difference of squares. So it should factor then to two conjugate factors. Well, the first term must be x and x so that I get the x squared, and then it would be plus 2 minus 2 to get the negative 4. And again, if you multiply this out, we would get x squared minus 4. So this expression factors to x plus 2, x minus 2. So the last expression, again, I want to recognize this expression. It's two terms, again, and I have a perfect square. 49 is a perfect square of 7. And then I have a perfect square 9, which is 3y. So this, again, we recognize as a difference of squares. So it will factor to conjugate factors. So if I look at the first term, what do I need to square to get 49x squared? It would be 7x. So the first term has to be 7x. And then I'd have plus and minus. What do I square to get 9y squared? Would be 3y. 3y. So this would be conjugate factors 7x plus 3y, 7x minus 3y. So we're looking for difference of squares, and then we know that that expression has conjugate factors. So the next nicest type of multiplication that we did was squaring a binomial, what I call BS. So we have a binomial and it's squared. So this is in factored form. When we expand this, notice we expanded it by just taking the first term and squaring it. So that first term would be 9x squared. The last term is the last term of my answer. It would be 5 times 5, or plus 25. So again, we take and square that. And then the middle term, remember, comes from multiplying those terms together and doubling it. So the middle term becomes positive 30x in this case. So what I want us to be able to do, again, is recognize this type of expression. So when I do have, and I have a binomial squared factors, then what type of expression am I getting? And at least for this, I am getting a trinomial. I will always get 3 terms because I get that middle term doubled. So I will get a trinomial. And some of the indicators is that the first term it has to be a perfect square, and the last term has to be a perfect square. So down here, I wrote an expression to generalize this. What is an expression? If I notice again, the first term has to be a perfect square, the last term has to be a perfect square, and then there is a middle term. This is what the middle term will be, but for all intents and purposes, we want to try to recognize this expression. So I'm just going to call this a perfect square trinomial, because I want to make sure it has the 3 terms, but my first and last terms have to be perfect squares. If that's the case, then we should end up with a binomial squared factor. This would be an A plus B binomial squared. So we should end up with a binomial squared, or a BS factor. So let's try these problems here. Again, it's more recognition than anything. So we have 3 terms, so it is a trinomial, and the first term is a perfect square of x squared, and the last term is a perfect square of 9. So we want to try, is this a perfect square trinomial? So if it is, then it should factor to a binomial squared. The first term has to be x to get the x squared. The last term, we notice, has to be the square root of 9. It could be positive or negative 3. So if we just put positive 3, then we just need to make sure that we check the middle term. So make sure that we mentally check the middle term to make sure. So if we multiply 3x and double it, we do get that middle term. So this is a perfect square trinomial, and it does factor to a binomial squared. So again, let's look at this last one. I have a trinomial. I want to recognize I have 3 terms. The first term is a perfect square of 2x squared, or of 2x. And the last term, 49, is a perfect square. So I think this is a perfect square trinomial. I'm going to try a binomial squared factors. So the first term has to be 2x to get the 2x times 2x, or 4x squared. And the last term has to be 7 to get 49. So now my middle term, if you notice, is a negative 28. And if you multiplied these, you would get a positive 14x doubled. So I need to make this a negative 7 so that my middle term ends up to be negative. So this would be a negative 14x, and if I double it, I do get the middle term. So two types of expressions that have nice binomial factors. The first type is a difference of squares. A difference of squares has conjugate factors as binomial factors. And then if we have a perfect square trinomial, these happen a lot, and we should hopefully get used to recognizing them. Then the factors are just a perfect square or a binomial squared factor.